Hi, welcome to our presentation on material selection for spanner. My name is Samuel and this is my teammate Sidharth. Today we'll explore the considerations behind choosing the optimal material, balancing cost, performance and sustainability. Firstly, let's take a look at our engineering tools spanner. Why is material selection important, you may ask? The material chosen for a spanner can impact its performance, longevity, and overall user satisfaction. Now let's delve into the key factors influencing our decision. Spanner, also known as wrench in some regions, are versatile tools used for various functions, primarily in tasks related to tightening or loosening nuts, bolts, and other fasteners. For its applications, spanner is widely used in automotive repairs as it is a primary tool for tightening and loosening nuts and bolts on engines. Other than that, spanner can be used in household repairs and DIY projects, and it is a versatile tool for assembling furniture and fixing appliances around the house. Lastly, it can be used for manufacturing and industry, and it is integral for assembly line tasks and the routine maintenance of machinery and engines. Now, allow me to let Sidharth to introduce the key properties and their applications.
Thank you, Samuel, for the introduction. There are a range of key properties to consider while choosing a material to make a spanner. A spanner has heavy-duty applications as well as light-duty applications. It is used in a range of things in the industry. First key property is the tensile strength. Higher tensile strengths make sure the spanner can withstand forces. Since it's used to tighten nuts and bolts manually, there are a lot of tensile forces acting on the spanner. Second key property is yield strength. A higher yield strength means the spanner can handle more stress without permanently deforming. It ensures a long lifespan for the spanner. The third property is ductility. While stiffness is crucial and prioritized, a good degree of ductility makes sure the spanner can absorb energy and deform without breaking if there's an extreme load, and it helps avoid injuries to the consumer. The fourth key property is fatigue strength. Fatigue strength is a critical property since it helps resist the development of cracks and fractures due to repeated stress cycles on the spanner. The next key property is impact strength. Good impact strength makes sure that the spanner can absorb and dissipate energy from these impacts without breaking or deforming excessively. This contributes to long lifespan for the spanner. It is important for the spanner to be resistant to corrosion as it is used in aggressive environments where it contacts with various pathogens and moisture. Wear resistance is another key property as it is directly related to the spanner's lifespan. A high wear resistance means the spanner can be used for a longer time and also reducing the cost of expenditure. Modulus of elasticity or Young's modulus is important. While flexibility is favorable due to ease of use, excessive flex can reduce the efficiency of spanner. So a moderate amount of Young's modulus should be good while choosing a material for the spanner. Lower density is desirable for weight considerations, as if the spanner is too heavy, it might not be easy to use for the consumer. While density can't be the solo decider for the material, it is however important as the spanner's strength is also important as it is used to tighten nuts and bolts which can be heavy and hard to do at times. So a higher weight of the material ensures it's easy and less force is required to tighten various fasteners. The most important criteria is cost. Spanners are small but yet important and highly used tools in the industries of automotives and even small chores like furniture. Hence, cost is important. The material we choose must be economically feasible so that it can be mass produced without having high costs. Now we'll look at the first contender, which is AISI 316 stainless steel. It has high strength comparable to titanium and more than aluminum alloy. It has high corrosion resistance, which is again on par with titanium, and it is the cheapest contender out of all the three we have, and it is a perfect market fit. The only disadvantage of stainless steel is it's heavier than aluminum, which can cause the consumer to be tired if using for a prolonged time. The second contender is aluminum alloy of grade 6061T6. Aluminum alloy is strong, but not stronger than steel or titanium. It deforms easily and is not the best choice for making a spanner, as a spanner prioritizes strength. It is resistant to corrosion, but again, not as much as stainless steel or titanium. And it has two downsides, which is lower strength, which makes the consumer tired if using for prolonged period, and it has very low wear resistance, which harms the spanner's lifespan. The third contender is titanium alloy of grade TI6AI4B. Titanium alloy is the most elite material to make a spanner. It has highest strength, high corrosion resistance, and also comes with low density. But the disadvantages has only one disadvantage, which is its cost. But cost is a crucial factor since spanners are mass produced. Titanium's exponentially high costs as compared to stainless steel and aluminum alloy make it less favorable for making spanners. Now we can see a direct comparison of the materials and key properties. As we can see, titanium alloy excels in most of the properties with a far range. It has a high tensile strength, high yield strength, and wear resistance and corrosion resistance is high as well. But due to its high cost, which is 10 times more than stainless steel, it becomes less favorable for utilities such as spanners or other tools. It is suited more for jewelry and such. Stainless steel performs well and comes with a good cost. Its cost to performance ratio is higher than all three contenders. It has a good tensile strength of 680 MPa and a good yield strength as well. It has low ductility and it performs the best in the Charpy impact test. Its corrosion resistance is not as high as titanium alloy, but is on par and sufficient for the day-to-day activities. Now, my friend Samuel will throw light on sustainability and socioeconomic considerations.
Thank you, Siddharth. After looking at the comparison, our final decision for the material selection is to be using the AISI 316 stainless steel. Now, let's take a look at the sustainability first of the material chosen, which is steel. The recycling rate, based on figures found from the World Count website, shows that the recycling rate of steel is up to 60%, which is relatively high compared to other materials. Other than that, carbon dioxide emissions data from Sustainable Shield shows that it is 11%, which is very low and it's very good contributing to the environment. For the socio-economic part, data taken from shopping website, which is Shopee, shows that the market price for a spanner is roughly around 6 ringgit 90 cents to 15 ringgit, depending on the size and materials. It is worth to take a note at the durability of steel, which is highly durable, making it to be able to have a longer lifespan, contributing to resource efficiency and reduce waste. In conclusion, stainless steel is well-rounded, offering high strength, corrosion resistance, and affordability. Aluminum alloy is ideal for reducing weight but may sacrifice some strength. Titanium alloy provides an excellent strength-to-weight ratios, but when it comes to the cost, it is way too high for a simple tool-side spanner. The decision should consider factors such as the intended use, budget, and the importance of specific properties for the given applications. Considering the most important factors such as strength, corrosion resistance, cost, and weight, stainless steel AISI 316 would be the most suitable material for making a spanner. This is because stainless steel offers a good balance between the lightweight nature of aluminium and the high strength of titanium. It provides superior corrosion resistance, ensuring the spanner's longevity in various environments. That is the end to our presentation. Thank you for joining us.
Thank you.